See a lot of familiar names here.
Good evening, everyone.
Good evening, good afternoon. I would imagine most people are out of the morning, right?
Probably. I mean, we could have a look at a world time zone.
Yeah, right.
I mean, I'm fairly sure it's the morning for Australia.
Oh yeah, yep. It's the morning of the next day instead of
Yeah, so it'll be Wednesday morning in Australia.
Yeah.
But I suspect it may be the middle of the night that they're still, because they are 9 hours ahead of me, I think. Which would put it at 6 in the morning or something. Yeah, 5 in the morning. You have to be really dedicated and really love Airflow to catch this live from Australia.
Right.
So welcome to the two of you with insomnia from Australia.
See, we got France in here, Portugal, Seattle. Oh, it's midnight in India. That's showing some passion there. As usual, we'll wait until about 5 minutes after to get started. Cordoba, Boston, Toronto, Denver. Ash, every time I do one of these, I say I'm going to write a little bot that just like scrapes the locations in here and just like lights up a little map in my background that says like, oh, look, where everything's jumping on for.
You should do that. You've got until I finish the presentation to get it live. Go.
All right. I'll go off camera and get started, and then I'll see you all at the end then.
There we go, yeah.
Yeah. Clearly, I've made a ton of progress. Yeah, there'll definitely be a DAG there.
Clearly should be a DAG, yeah.
Yeah, it might even need a timetable for that.
Exactly. You'll find out about that in a minute.
All right. Give about 3 more minutes before diving in.
Cool.
What are the days before a big Airflow release like? Are they more hectic than usual? Are they less hectic than usual?
They're pretty much all hectic, yeah. Kind of just massively trying to fix all the bugs you can and just squish everything that's possible and things like that. Yeah, trying to make sure there's no regressions that I haven't suddenly made performance 10 times worse or anything like that.
Imagine.
Trying to make sure that no big changes get snuck in because someone doesn't know the release is coming up as well. So, you know.
Yeah, you got to release engineering really is God's work. It's just it's like unappreciated sometimes, but I feel like so many little things have to go right to make that happen.
Yeah, it can be very, very underappreciated and almost invisible work if you do it well. Thankfully, I'm not the release engineer, the release manager for this one. That honor falls to Jed. His first time, so you know, to some extent, doing the release work for the first of a series, so 2.2.0 is easier than 0.1s, 0.2s because you don't have to do any backporting to start with.
Interesting. Gotcha. Well, we will certainly give Jed a shout out here. I guess you're just playing the role of evangelist on this one.
Yeah, I'm just taking credit for everyone else's work. Very little of the features here are actually things I've contributed to. I've just been kind of shepherding people this time around. But yeah, maybe if we have time, I can hint at some of the things that are coming in the coming releases. So we'll see how we get on with time.
Yeah. So I think we're just about go time here. I can kind of kick us off here, get things started, and Ash, I'll pass it to you for all of the fun stuff. Yeah. So first off, thanks everyone for joining us in your morning, evening, or night. You know, we have folks all around the world. Super excited about this webinar. This is our bi-weekly Tuesday webinar. We try to go deeper into Airflow or data engineering concepts, and really excited about this one, just given the timing of it, as we're pretty much on the eve of the Airflow 2.2 release. So we have here with us Ash Berlin-Taylor, Director of Airflow Engineering at Astronomer, and he's going to take us through everything you need to know about Airflow 2.2. Sorry, I'm still used to saying 2.0 for whatever reason, and I've said it so many times. Yeah, it's going to be a little different than our normal webinars, just because we don't have the demo the same way we do at the end, given that 2.2 isn't out yet. But the following ones that you'll hear about are going to be kind of a little more focused on 2.2 concepts and new features and so on. So plenty coming there. This one just is going to be our high-level overview on what's to come, and we're very excited about it. Just a couple of logistic notes before I kick it off to Ash. The recording, as well as code samples we do show, will be sent out to you afterwards, so be on the lookout for those. And then, as always, feel free to drop questions in the chat or the Q&A, and we'll either get to them in line or after the presentation. I think I've said all that I need to say. So with that said, Ash, I'll hand it off to you.
Great, thanks very much, Viraj. Yeah, so for those of you who don't know me, I am Ash, Director of Airflow Engineering here at astronomer.io, and I am also on the Airflow Project Management Committee, which is a big fancy word for saying I'm a core contributor and we get to vote on who else can become contributors. But yeah, so I spend a lot of my time working on open source Airflow and generally just making it better for everyone. Yeah, so I'm just going to talk today about 2.2. So 2.0, I'm sure most of you will know, 2.0 was released in December last year, and since then we're following roughly a 3-month release cadence, though not quite, because that would in fact mean we'd be at 2.3 right now. But anyway, so yeah, 2.2. This has actually been a really big release. So there's a couple of big features, which I'll get onto in a minute, but just kind of, yeah, this is, I think, since 2.1 kind of was released, or new commits since 2.1, not included in a 2.1.4, etc. About 500 commits. So quite a big release, all told. And it's got 2 big features and a whole load of small, just kind of quality of life improvements to just kind of like make Airflow more powerful and fix some long-standing issues that were just kind of like, oh, this should be fixed. We should expose that or improve that. But yeah, so kind of the big ones here in green and blue. Deferrable tasks. So this was AIP 40, which is just, kind of making Airflow more efficient for lots of the common workloads. Custom timetables, which is making Airflow scheduling much more powerful, rather than just being stuck with the kind of scheduling on a fixed interval and having to put lots of branches or skips in place. You can now have fully customized timetables that run your tasks, your DAGs exactly when you want. And then it's both big and small, but the task.decorator one, task.docker, decorator, you can easily take a Python function and run it in a standalone Docker container. So yeah. So starting with the middle one, because AIP 39. So AIP stands for Airflow Improvement Proposal. So any kind of big architectural change or kind of like a fundamental change to the way Airflow operates goes through what we call the Airflow Improvement Proposal process, which it's not that big or onerous. Basically, it's someone writes up a proposal saying, hey, I want to make all the links purple and flashing. For example, you write it up on the wiki, you discuss it on the mailing list, then people kind of vote on it, and if the vote passes and people do it, then you can start working on it. But this is just to make sure that big fundamental changes get buy-in from the community. And those votes are open to anyone, committer, PMC, just interested onlooker. You're all kind of welcome to join the dev mailing list and get involved in those. So AIP 39 is called like custom timetables and general scheduling improvements. So as I was saying, cron expressions can only get us so far. There are 3 types of things you can pass to schedule interval. In previous versions, none, which says don't run on any schedule, just whenever I trigger it, whenever I hit that button in the UI, that's the only time it runs. So that's kind of the easy case. There's the cron expression, the 5 things that everyone has to look up and go to cron tab guru every time to remember it. Don't worry, you're not the only one who does that. I work cron all day and still do that. Or you can also pass a time delta, which says just run exactly every 30 minutes, whatever. Those can only get you so far. So like a fairly common, I guess, pattern is, hey, I want to process weekdays data. And I want to process it at the end of the working day, which is fine because, Monday will run, Monday's data will run on Tuesday, Tuesdays on Wednesday, yada, yada, yada. Gets up to Friday's data. And then the way Airflow works currently, it goes, oh, I'll start at the next schedule. So Friday's data doesn't actually get processed until first thing Monday morning, which is often not what you want. So yeah, this is what we changed. It's fully backwards. This change is fully backwards compatible. Schedule interval is not going away. Like cron expressions are very simple and they make perfect sense for the kind of the use cases. Yeah, sometimes it's like, no, just run on a cron, it's fine, that's easy, that's staying. Timetables have also, so the AAP, we're calling it timetables. We've introduced an explicit new concept of a data interval. So before, this was kind of, it was implied and it was hinted at, but now it's kind of like here. There's a data interval start and a data interval end. If you are doing an ETL kind of job or any kind of job where you're looking at data for a period, rather than having to use like DS, for date stamp or execution date and next execution date or previous execution date, which was all kind of just like working around the problem, there's now like two new template variables called data interval start and data interval end. And your task should look at that window of data. Also, execution date is going by the wayside. This concept is universally confusing to everyone who picks up Airflow. Yeah, it's kind of like, hey, it's Tuesday. Why is my DAG from hey, it's coming on Tuesday morning. They're like, hey, why isn't my DAG for Tuesday one? Why is it a day late? So we're renaming that, and we've done a few UI tweaks as well to make it more obvious when things are happening. I'll get onto those in a minute. But yes, the execution date is being renamed to logical date. The renaming won't be complete in this release, so there'll still be a few places where in the docs or in the UI it still talks about one or the other, but we'll correct those over the next couple of point releases. So yeah, execution date gets renamed to logical date. And then the data interval concepts, there are two new template variables there. Data interval start and data interval end. Those are date times. So data interval start is kind of the same value as execution date. And data interval end is currently the same value for next execution date, but it's up to the timetable what values these have. So, if you've got a daily DAG and you want to look at a day each time, that's currently, that's what you get. But if you wanted to have a daily DAG but have a look at 3 days, then you kind of can easily make your timetable give you this moving window of 3 days. And it's all kind of handled. As long as you return the right values from your timetable, it all just works. So timetables are pluggable. They are user supplyable code. There's a few built-in timetables, but those mostly just kind of mirror what the existing functionality that 3 different parameter types you can pass to schedule interval do. But we can write our own. So here's a very rough timetable. This is not complete. Doesn't handle everything. There's actually a couple of extra methods you would need to write, but there's 2 main functions. Let's say, for instance, that we wanted to create a timetable that gets rid of that execution date confusion. So I want my Tuesday job to run at midnight on Tuesday, not midnight on Wednesday. So I want to run at the start of the period, not at the end. This is pretty much the code you would need to do that. So infer data interval is used whenever you click the trigger button in the UI. So basically, like when you're given this date, please tell me what the interval should be. So yeah, that's kind of when someone manually triggers it. It's like, what should the interval be? And then next DAG run info, kind of what it sounds like, which is giving you info for the next DAG run. So there we are. We're just kind of creating the next one, and Oh, that's not actually right. I'm returning the wrong type. Forgive me, I wrote some code on a slide instead of in an editor. But, you know, you get the idea. Don't try and run this code, it won't work.
Well, I think like as a data engineer, these sorts of timetable things, it feels really valuable to me for two reasons. Number one, helping a user get started. I've had to explain execution date at least 1,000 times, right? It's a little counterintuitive. But number two, and I actually think this is more kind of exciting, is anytime I have to schedule a funky interval, be it like a financial calendar or Ash, like you said, like I need this Friday's data to run on Saturday, not on Friday, right? I actually handle that logic at the operator level. And all of a sudden I have a bunch of custom logic and these operators I have to maintain. And that just really slows myself down. So it sounds like I can just handle my scheduling logic, my custom scheduling logic in its own thing, kind of maintain it separately than all my other operators. Is that kind of a good way to think about this?
Yeah, exactly. It to try to make everything a bit more explicit, a bit more declarative rather than kind of imperative. But yeah, just kind of exactly. And I haven't mentioned it here. There are plenty of docs on how to actually go about writing your own timetable. You can install it via a package, much like we do with kind of providers and all the hooks and the hooks and the connections. Or you can register a timetable via the plugin, so you can just add it into your tree, into a plugins folder, and using the kind of the existing Airflow plugin mechanism. So yeah, it should be super easy to have like some timetables in your kind of in your deployment without having to learn Airflow packaging and all that kind of stuff like that. But yeah, so what can you or can't you do with ignore that last point. I clearly put that in the wrong place because we haven't even talked about trigger yet. Pretend that's not there. You didn't see it. So what can't you do with timetables? This is not event trigger DAGs. Not yet. Come on to that in a minute. So timetables are evaluated inside the scheduler. So it's kind of whenever the scheduler goes to create a DAG run, it evaluates the timetable and says, "Hey, I've just created a DAG run. What's the when should I create the next one?" So it's kind of like, so you can't make an HTTP request and go, should you schedule this now or not? So keep it quick, keep it consistent. So given the same input, it always produces the same output. If you want like event trigger DAGs or something like that, that's coming. That's not this feature. This is just I want to produce it then. Yeah, and they're evaluated in the scheduler. So don't do anything that takes too long. You'll slow down that scheduler and lock it up. There's no kind of protection here. So this is, be careful what you do here. So I mentioned that 2.2 is going to ship with just kind of like the three built-in, effectively the three current behaviors. But if you're an Astronomer customer, we have built out for you a trading hours timetable. So if you're kind of dealing with financial data and want to run a DAG immediately after close of the FTSE, not the FTSE, that's the UK one, sorry, of New York Stock Exchange, you can do it. That's kind of the simple one, which that runs immediately after it. There's a few other things. You can delay it by an hour. You can run at the beginning, things like that. But yeah, this is one of the prime examples of where a timetable becomes useful, because it's like, this is a predictable scheduler, but it's not a predictable schedule, but it's not a regular schedule, and it doesn't easily fit into a cron expression, or if it does, you then have to have a whole lot of branching in conditionals, like if it's holiday skip or if it's a weekend skip and all that kind of stuff like that. So being able to package this up once and just reuse it, it's a lot easier to see what it's doing if you've got something like this.
Ash, I want to make sure I'm understanding this correctly. This feature are custom timetables. It's not dynamic timetables, right? So it's not something like, hey, go reach out and check something. It doesn't remove the need for those checking conditions in your DAG, right? Be it the branch operator, the trigger operator, but it's more
exactly
like
that. It is not checking something. It's just kind of tell me when I should trigger the DAG. I will come back onto kind of event stuff there. to answer Jonathan's question from the chat, I presume devs will end up creating a set of common timetables that any DAG can import. Is there a way that those timetables can be displayed in easy to understand table of options for less technical users? Depends what you mean by table of options. I'll come back to your question at the end. We do show something in the UI which the timetable can customize. Yeah, so they kind of, yeah, if you are an Astronomer customer and want to kind of use this timetable when 2.2 is out, get in touch with support and we can tell you how to try it out. So that's it for AIP 39. Now we're on to AIP 40, which is deferrable tasks. So fairly common pattern for Airflow. Kind of, there are two real ways people use Airflow to process data. The first is I'm going to use Airflow purely as an orchestrator. I'm going to make it kick off jobs elsewhere, and I'm going to wait for them to complete, and then I'm going to make sure the downstream goes. That's kind of one. The other one, which I guess is kind of not as common, but it's still not uncommon at all, is to do your heavy processing in Airflow and have beefy workers. This one doesn't really help you with that. It helps with the first case. Kind of, if you've got a traditional operator, you kind of, each worker slot, it submits a job, and then it sleeps for 30 seconds. And then it checks, makes an API request, goes, hey, has this job completed? No, I'll sleep for another 30 seconds, which is a really expensive way and very resource wasteful to do it. So deferrable operators completely turns it on its head and makes each task able to say, like, I'm done. Here's a small callback. Tell me and resume here when I'm done. So yeah, the ideal use case for deferrable operators, kind of deferrable async, we use the terms somewhat interchangeably. It's great for anything that submits a job to an external system, particularly over a network call. The main advantage of it, it doesn't consume a worker slot, as I mentioned. So kind of, your Airflow workers, by default, you'll have, let's say if you're using Celery and you got a couple of gig and you've got 10 to 16 slots available, if all that slot is doing is sleeping and then making that request and then sleeping again, that's really bad. That uses a lot of stuff. So if you've got this kind of heavy workload, you should see a vast improvement. So kind of the way this feature came about, for Airflow 2.0, Airbnb introduced a feature called Smart Sensor, which was their tackling for this. So kind of their workloads, they had a lot, something like 60 to 80% of their Airflow cluster was taken up waiting for files to arrive in their HDFS cluster. So they built smart sensors and kind of contributed it back open source. And this deferrable framework, deferrable task, is that takes that concept, builds upon it, and generalizes it to anything. So this doesn't apply just to sensors. You can have an operator defer just as well as a sensor, and it also doesn't need a DAG running. So the way smart sensors was implemented was there was kind of a DAG that was running that was the smart sensor, kind of the smart sensor engine. So yeah, this is kind of a lot more general, a lot more kind of special purposed, and is async. So yes. Advantages of async. Use less resources. I've hammered this point home, but yeah, it's just kind of, it's so fundamental to this that if you have a sensor heavy workload or a network request heavy workload, so if you do a lot of things with GCP or a lot of things with AWS APIs where it's like, hey, submit a job over an API and then poll for completion, converting these operators to be async will save you a lot of compute needed for Airflow. Another advantage is it's resilient against restarts. So because the way the async operators are written, they kind of serialize into a table and say, like, here's a minimal state. So you can completely restart your Airflow cluster and the deferred operators will come back and keep checking exactly where they were before. So yeah, that's kind of a huge bonus for if you've got, again, it's like you can survive a restart of your Airflow cluster without terminating jobs for most cases here. And the other thing that this does is it kind of paves the way for more async features in Airflow. We've now got async IO in core. So once we've got it, we can start to use it for such as event trigger DAGs. So I'll come more onto that. That's not a feature we've scoped out yet or planned. But it's like, hey, we've got some ideas. Let's work out what it can look like. So how do these async tasks actually get run? So there's a new component in Airflow. So previously we had the scheduler, the web server, the worker, which I've started calling the runner, and then off the Redis, but that's kind of component or not. There's a new component called the triggerer. So the triggerer it's a new daemon, and it runs the async IO event loop. So every deferred operator, when you defer an operator, I haven't gotten into any detail in how to do this. I will put a link to the docs. Andrew, who wrote all of this feature, Andrew Godwin, he is async IO Python is kind of his bread and butter. He's a Django core contributor and has done most of the async work there. So it's only natural that, of course, the first thing he does here is do async work. When he started working on Airflow, he's written a really good guide about how to create a custom deferred operator. Basically, when you defer the operator, you say, when you're done, call me back here, and here is a triggerer. Like here's a class path to some async IO code to run, and they all get batched up together in this triggerer. And you can have we've tested with 500 triggerers in one process, and they all just kind of work together well. So yeah, if you're going to be using async operators, you will need to run the triggerer. If you don't, and you end up having one, you'll get a notice in the UI saying, "Hey, the triggerer is not running." So, how many async operators are there? Not many for now. In 2.2, there are literally these two. Date time sensor async and time delta sensor async. So right now we've taken the approach that it is better to be explicit, so that you have to change the name of the class that you import from, and then when you use these, if you either of these two kind of sensors, that task will end up in a deferred state, and when the time's elapsed, it will kind of come back and trickle through. Nicholas asks, what's the pro con of this versus a time sensor when it comes to the worker resources? The primary thing is that your workers can then do more useful work. Because these are both very simple in terms of the async code, which is, hey, we're going to sleep for some time, which basically means they do nothing. So you can run almost an infinite number of these. Each async coroutine or greenlet, depending on how you want to call it, uses a few extra bytes, so you can have lots and lots and lots of these in one trigger process. The trigger is, of course, HA, highly available from default from the get-go, so you can run more than one of them. But yeah, it's just kind of like, we think this works, and we've tested a few of them. So again, if you're an Astronomer customer, we've got four extra async operators that we're kind of testing and building out. And if you'd like to use these, when 2.2 is out on our platform, you will be able to get in touch with support, and we can tell you how to use these ones. So if you're using Databricks, it now doesn't need to take up a worker slot. So hopefully your compute, you should be paying less for compute. And then the next, so that's it for ARP39. It's kind of introducing async IO into Airflow, and to do wonders for sensor heavy workloads, or kind of like submit and poll heavy workloads, just to make Airflow be able to do more at once.
Hey Ash, one more question on that from Javier in the chat. How can you think about an async sensor? Can you just go over how it's different than using reschedule mode for sensors versus if you're using an asynchronous sensor?
Yeah. It is shorter, and it is so like reschedule mode basically gives up its well, to start with, reschedule mode only applies to sensors, so operators can't go into reschedule mode. And then the time and the frequency with which you can call back. So reschedule kind of, you can try to call back kind of instantly, have a very short like reschedule time or whatever it is. But that kind of has to go all the way back to the scheduler, get kicked through, go through the executor, get assigned to a node and run again. Whereas async IO is just kind of there. It's cooperative multi-threading. So when you say I want to run, or when your IO finishes, you get to check and then you can do another task. So it can be a lot more immediate. So yeah, it's kind of, again, most reschedule sensors could be converted to async fairly easily. And yeah, you'll just get them quicker. So once they're running, they're just kind of you get a bit quicker response times and more immediate. Other than you could easily run an async check every second. Whereas doing that kind of speed on a busy cluster with reschedule might be tricky.
And I guess I have one more question. I know this one's a little bit biased based off of situations I've run into the past, but you talked about how resilient the async operators are.
I'm sorry, I just lost my headphones, so I can't hear anyone at the moment.
Oh. The joys of
Ran out of battery.
Oh. All right, let's give you a minute here. You know what it is? We spent so much time rehearsing that the headphones ran out and ran out of battery. Can you hear us now?
Yes, there we go. Sorry about that, everyone.
Perfect, no worries. Was just hoping you could say a little bit more about the resiliency around async operators, right? Especially in situations where maybe I'm running, a ton of long-running Databricks jobs in an environment where I have a lot of users pushing code. How does the resiliency around the trigger kind of help in those situations?
Yeah, so the triggerer looks in the database. It kind of there's a new table, probably called triggers. I would have to check to be sure, but that's what I would have called it, and Andrew is sensible, therefore I'm going to assume he called it triggers. So the triggers table, and it tells like, hey, here's this class, or here's a class path, and just kind of here's some parameters for it. This policy is kind of how they should be written, not as such a design of the system, how it's implemented, but triggers are kind of like everything we say in the docs guide you into kind of creating an idempotent process of, hey, I'll check. And so in the example of a Databricks job, I'll make a request to Databricks and I'll check the status of this job ID. And that job ID is either running or success. And it doesn't matter if I shut down, I've got all that information in the database, so I can just start up again and check again. And to answer Sarah's question, which is related, it's nope, sorry, Jason's question. Will the UI treat async operators any differently? It colors them slightly different. So unfortunately, we've introduced another color. Working on that, but yes, so they will be. There's a special color for this task is deferred. I think it's purple color. The color is clearly important. But yeah, so it's a nice purple color, so you can say, hey, this task is like, it's doing something, but it's not consuming a slot. And Sarah asks, do you imagine that smart sensors will ultimately be replaced by async operators? Yes, I do. Smart sensors has always been marked as an experimental feature. So once async operators has kind of been proven for more than just kind of our workloads and the people we've been able to test with, we plan to remove smart sensors, probably let's say Airflow 2.5 kind of time frame. Because it's been experimental, we reserve the right to delete it. We may choose to keep it for longer, but yes, the goal is that async can replace everything that smart sensors was used for, and more. Cool. So onto the Docker decorator. So one of the complaints about Airflow is if you have any kind of complex dependency, you can end up in a situation where you can't really use the Python operator because Airflow and Team A and Team B all have a conflicting set of dependencies, so you can't get everything you need installed. So you can't just use the Python operator. In 2.2, we added a new feature, the task.docker decorator. Lets you do something like this. So what you do is you give it a function, you decorate it with this and say what image to run it in. And we handle sending this code across, getting the result back, sticking it in XCOM. So this kind of builds upon the task.virtualenv that's already exists, task.virtualenv decorator, which already exists, but kind of makes it for Docker decorators. So if you have big images you want for some tasks where you need a really expensive machine learning library installed, but it kind of slows down pulling images or whatever, you can use that. The one caveat for this is because of the way the code is extracted or transformed, you need to make sure that any imports are inside the function. So you can't rely on something imported at the top level of function inside your decorated thing. Check out the docs for more information on this. But yeah, this is kind of, it's a small feature, but it's a big one. The other thing that this does is because Airflow 2, we have split out kind of Airflow core and providers. The Docker operator is no longer part of core. So kind of like task.docker should live with the provider, but because of the way the code is structured, how do we get that? So this also means that if you're ever in the realms of writing a custom provider and you want something like this for yours, you can add whatever you like. You can register task.x. It's kind of added to the provider interfaces. You can now register new task decorators. So opens up the possibility for making your own decorators that live under task.
And I don't think that's small at all, right? I think like especially the syntax being simplified is just so good, so much for maintainability, especially across large user bases.
Yeah.
That's awesome.
Cool. So that was it for kind of like the big ones. What's the difference between this and the kube pod operator? Functionally, very, very little. But one of the next things we might kind of do after this, it will be a generic task.container, let's call it, which kind of abstracts away. You as a person managing an Airflow deployment could say, "Hey, here's how to run containers. I'm in Kubernetes, so just run them in Kubernetes." Or I'm on bare metal or on a VM. Here's a Docker thing. So you could wire it up so that task.container will either run in Docker or in Kubernetes, kind of depending on how it's all configured. We'd have to target kind of lowest common denominator there, but yeah, I guess also go back to the earlier point about Airflow and different libraries having conflicting dependencies. As you can see in this example, we're using pure Python thing, so we need almost nothing installed other than Python in the container. So yeah, kind of you can use this with a lot if you're if you are already good at building, already got some process inside to build Docker images. You can build an image for a particular task or a set of workloads and then reuse it. Will I need the Docker image installed on every worker? No, you won't need it. It will be pulled on demand. So this is just wrapping effectively the existing Docker operator. It kind of behaves very similar to the Docker operator. It's just kind of it's a built a custom command, and we extract the source code for your task and stuff. Rafe asks, can we think of this as a wrapper on the Kubernetes pod operator with XCOM for the return values? And does it run on Kubernetes? Kubernetes pod operator can already do return, but it's a little bit weird. You have to write the output to a file in a particular location. So this is kind of the same thing, but just Python. Yes, it's very similar. Does this run on Kubernetes? No, not currently. This is just Docker. So you need a Docker daemon configured that you can speak to. As I say, task.container would be going for Docker or Kubernetes, depending on where you're running. But that doesn't exist yet. Something someone should add. So that was kind of, hey, my big headline features. But then I realized there was five or so more little ones, and then hundreds of more tiny ones after that. So I picked out a random kind of sampling of some little features that I think are particularly cool. So first up, DAG.params. So it is possible when you are triggering a DAG manually, you're given a JSON blob, and either in the UI you get a field, or you can give it over the UI. But there's no validation of that until now. So when you define the params that a DAG can accept, you can give it a JSON schema. So it's not the full schema structure syntax, but the parameters, the validation, the library used under the hood is JSON schema. So you can say, hey, I need an int parameter, and it's got a default value, and here's the range. Or there's lots of things like this. This means we can in the future, but haven't yet. We can have when you trigger a DAG, you can give some nice error checking and have separate fields rather than just an unwieldy JSON blob. You can split it out into separate fields because we already know what they're like. This also lays the groundwork for true parameterized DAGs. So right now, if your DAG has a schedule of anything other than none, every parameter has to have a default. Otherwise, it will be a DAG parse error and it won't allow it. But I want us to build. It's kind of already in my head. I know how I'm going to do it. Build DAG parameterization in Airflow. So you can go like, here's a set of parameters for this DAG, and here's 3 different sets of parameters, and every time you trigger the DAG, I want these 3 to run. To do that, we also have to get into the place where you can have more than one DAG run per execution date. So, because you would need, if you've got 3 parameter sets, and you want to run this DAG every day, you would need three different DAG runs for Monday, say. So a lot of that groundwork was laid in AIP 39, where we removed execution date from a lot of places and deprecated it. So yeah, a lot of that groundwork's been kind of done already. But yes, so kind of like you combine these two, and then you get this kind of ability to have like DAG parameter sets, and then every time it's triggered, it just runs. So if you're pulling from a Google ad campaign, it's like, hey, here's my 3 different ad campaign, here's my IDs, here's the markets and stuff. You can just go and pull it. So that's kind of going to be cool. And then the next one, again, it's just kind of quality of life. We've added a test button in the connection screen. So whenever you're adding or editing a connection, there's now a test button. You can check that the credentials you entered actually work. Sounds simple. It kind of a small thing, but it's a huge quality of life improvement. Also on connections, you can duplicate a connection. If you want, if you want 2 different MySQL databases, you can now do it easily. Guess who didn't change the title of that slide? Whoops. This is part of the timetables, but also you can now see when a DAG is going to run. So yes, kind of at the top here, we've got the DAG details view, and if you hover over the next run, and then on the homepage, you have the next run column. and the value it shows is the start date or the logical date. But then if you hover over it, the first thing it says is run after. So you can see when that's going to run. There's no more guessing and just kind of like, oh, this is every 30-minute DAG, so that one's going to run here. No, it's right there. Not kind of, there's too much information on that page, on the homepage, so it's not shown without a hover. But there you go. You can see, going to run after this time, and here's the data interval that it's going to process when it runs. And Airflow standalone, a new command. We have Breeze, which is running everything in a Docker container. But if you don't want to use Docker, there's now an Airflow standalone command, which runs all the components needed kind of as sub-processes of Python to just get everything running. So you don't have Docker and aren't comfortable with Docker, but you have Python installed. You can just do pip install Apache Airflow and then Airflow standalone, and it will stand up an Airflow server running locally on your machine. You can just get going and develop with it. So that was the end of the features I picked out. Time for questions if anyone has any.
I was gonna say that DAG parameter stuff doesn't seem like a small feature. That seems pretty huge. I feel like so many folks have DAGs that generically cycle through a couple of parameters, and it's like foundational stuff there.
Yeah, absolutely. So like the parameterization only works really right now when you are manually triggering. So kind of you would have to follow the kind of master DAG, which triggers other DAGs kind of approach right now if you want to do this more than once. But yeah, no, I think this one's going to be, again, this build some foundations that we can build some really powerful features on top of.
Yeah, it's awesome. Looks like we have a question from Gang in the chat regarding the task.docker. What's the difference between the Python operator with custom image next to your config and the Kubernetes executor versus task.docker?
Yeah, so the ease, the clarity with which you do it. Functionally, nothing. They achieve the same result. This makes XCOM slightly easier because you can just return it like you could from a Python operator. But yeah, like functionally, very little. This is just making it nicer and easier for people who are kind of not so au fait with Kubernetes and Docker and all the different things. Making it easier to run tasks in Docker. But yeah, it's a polish. It's a quality of life improvement.
Awesome. Then will standalone mode install a Postgres database?
I do not know. I haven't checked that, so I can't answer
that. All good. Yeah. Either way, I think just the cleanness of that one command will be huge for open source users.
Mm-hmm.
Awesome. I think we are just about close to time. We do have time for one extra round of questions in case anybody has any.
In YouTube, someone's asked, can you explain again the difference between data interval and schedule interval? Sure. Actually, no. The easiest way of explaining that will be with the screenshot of this. So I'm not sure if you can see my cursor. You probably can't. So the schedule interval is every 30 minutes. That's kind of the same thing right now. That hasn't changed. Don't click on the screen, Ash. The schedule interval is every 30 minutes. So for the existing kind of built-in timetables, schedule interval and data interval have the same period. But let's say you want to run a daily roll-up over the last 7 days of sales data. It's like how many what was my weekly moving sales? You can write a custom timetable that will run every day, but will have data interval set to 7 days ago, so that you kind of you don't have to think about, you don't have to do that calculation manually. You can just use data interval start, and that will be the start of your 7-day period, and data interval end will be the end of that 7-day period. And each day it will just automatically be the 7-day window set, with now at the end. That's kind of why we've split them to a separate explicit concept, because a lot of people were either doing this implicitly with execution date, next execution date, things like that, or you having to use like DS add and all the kind of do date time math in the operator. It just made it harder to read. And also, some of the use cases that were kind of when we were building this timetable feature, honest to goodness, there was an astronomer in Slack, like not someone who works for the company astronomer, but like someone who looks at stars. There was an astronomer going, "Hey, I want to use Airflow and I want to process the night's data. I want this to run at dawn." That's an easy schedule to say. It runs at dawn, but that's not a regular schedule. That moves. You kind of you bigger and smaller over the year. So this is kind of this is what you can do with timetables, and the data interval will change. It's predictable. It's fixed, but it will change depending on when in the year you run it. And going back to one of the very early questions someone asked about how are timetables handled in the UI. There is a property of the timetable object. I think it's called description, and whatever that returns is what gets displayed in that schedule column. So it's kind of you as a timetable author, kind of just down here where it says 0030. I can annotate my own screen. That's what I should do. So just down there, where it says 0030. That's controllable from the timetable. So you can have return human readable strings, you can return whatever makes sense for you. So that's kind of how timetables are handled in the UI.
Cool. It's going to be awesome. That's intuitive as well.
Couple more minutes, yeah. Jason is asking, could standalone command be used as a development tool to execute tasks on demand from the command line? Not in its current invocation. It will stand up an Airflow stack. So it will run the scheduler, it will run the web server, it will run the worker, and just start executing whatever your schedule says. So it's not designed for that right now. There are, if you want to test a task to a change, there are a couple of other ways already of doing that. There's Airflow task test, and I think there's also Airflow DAG debug, which would be better suited, I think, for what you're asking, Jason. Cool. Matthew is asking, is Airflow still not recommended for workflows only triggered through API calls? Yeah, no, you can do that fine. If you can use the API, the specified REST API, and have it reach into Airflow and trigger your DAG. I hinted earlier, how are we doing for time? We've got a few minutes left. Yep. I hinted earlier at event trigger DAGs. And there's lots of things that can fall under that umbrella. Inbound requests, like hey, someone posts to Airflow, go trigger this now. I think that's kind of doable already with, as long as you set up the API right. But maybe we create like a per DAG token, so each DAG gets a kind of a unique URL. If you guess that URL and stuff, I don't know. We can make something easier so that like here's a URL. If anything posts to it, don't worry about auth. It will trigger the DAG. That might be a security concern. I don't know, but that's one part of it. The other thing would be a chain of DAGs. When one DAG finishes and it produces some output, you there's many cases where you just want a set of downstream DAGs to automatically run. So that would kind of be built into Airflow. And the other thing we've been thinking is we've got this async event loop running in the triggerer. Why not let triggerers trigger DAGs? So rather than triggering off a schedule, you can trigger off files appearing in S3, and you have an async triggerer task running in the triggerer that's checking an S3 bucket every whatever for presence of files. You could also do that with SNS and notifications coming in, but just examples of, hey, we've got async, we can start doing a lot more things with it. So when it comes, so yeah. Ricardo has asked, do you have any programmatic alternative to the task.docker annotation? I'm not quite sure what you mean, but task.docker under the hood uses the Docker operator. So Docker operator, I guess, depends exactly what you're trying to do. And David asked, does Airflow have anything to easily import schedules and dependencies from other platforms such as Control M or Informatica? No, not currently. That might be something we at Astronomer are working on. Or, sounds like something we should work on, but we haven't started it yet. This is still a very new feature.
We've helped some customers through that journey, Dave. So that's definitely, if that's something that you're looking for some help on, please feel free to shoot us a note. That is something we've kind of assists our customers in thinking through, as well as help with kind of architecting what something like that could look like. Awesome. Ash, I think there is 2 more questions in the Q&A. And then I think those are going to be I think that'll take us home here.
Cool. One question for the same thing. Is it possible to rename the Python operator? Yes, there we go. Is it possible to rename the Python operator when using the TaskFlow API? I'd like to give it a name every time I called it. I would have to double check, but I believe you can pass a task ID parameter when you call it.
Mm-hmm.
You can define it, and I think you can pass it a task ID. If not, open a bug, because that kind of feels like the thing that should be possible. But yeah, Juan, I would try passing when you do like my function, pass task ID equals X in there and see if that works. I think it does, but I'm not certain. Cool. And if anyone, have any more questions after this, grab me on the Apache Airflow Slack, and I'm happy to answer some more questions.
Awesome.
Yeah. Final question.
Yeah, thank you so much. Ooh. There you go.
Yeah. Are there any improvements planned for parallel operators, either parallel maps or on a task in parallel on each element of a given list? Yes, there absolutely is. We're working on the AIP right now. We're trying to get 2.2 out so that we can kind of get the current set of AIPs closed. Yeah, watch this space. Actually, I'll probably give some more details about what we're talking about there next Tuesday at the Smart Data Conference. It's a Russian conference, but it's online. I'm gonna talk about what's coming in Airflow 2, 3, and beyond. So yes, watch this space. It absolutely is, Matthew. That's kind of my big nut to crack for the next release. So yeah, it's coming.
Right, so you're already giving a talk on what's coming in 2.3. So
really, I'm it's conference driven development. I'm going to say I'm going to do it, therefore I have to do it.
Right, that's the forcing function. We'll send out a link to that talk in the follow-up email here, where we'll send the recording out. We're just about out of time, everyone. Thank you so much for your time. This has been great. Ash, thanks for going through this stuff. Super exciting, and hope that everything with the release goes well. We'll send Jed some beer or something to thank him.
Thank you very much, everyone.
Thanks, everyone. Bye-bye.